Imagine a star, not like our sun, a familiar beacon in the daytime sky, but a cosmic ghost, a white dwarf, the spectral remnant of a once brilliant star. It's a stellar ember, fading slowly in the vast emptiness of space. This is the dense, smoldering corpse of a star, once like our own, a future that awaits our solar system billions of years from now. It's a glimpse into the ultimate fate of many stars in the universe. After billions of years of shining brightly, fueled by nuclear fusion, it exhausted its fuel and shed its outer layers in a spectacular display, a cosmic shedding of skin. This process leaves behind a core the size of Earth but with the mass of a star, a mind-boggling concentration of matter in a relatively small space. It glows with leftover heat, a residual warmth from its once fiery existence, slowly radiating its energy into the cold vacuum. Imagine a celestial skull forged in the heart of a dying sun, a haunting reminder of stellar mortality, a cosmic memento mori. Its gravity is hundreds of thousands of times stronger than Earth's, a crushing force that warps space-time around it, a testament to its immense density. And a teaspoon of its matter would weigh as much as a truck, an almost incomprehensible density that defies our everyday experience. The atoms inside are crushed into electron-degenerate matter, a bizarre state of matter where electrons are packed together as tightly as possible. This is a quantum state where normal rules break down, where the familiar laws of physics bend and twist under extreme pressure. Picture a diamond the size of a planet, a colossal gem formed from the intense pressure and heat, a glittering monument to stellar death. It's both beautiful and terrifying, a captivating spectacle with deadly consequences, a cosmic paradox of attraction and danger. Why fall into one? What compels us to imagine such a perilous journey? Because curiosity drives us to ask, what if? It's the insatiable human desire to explore the unknown, to push the boundaries of our understanding, even if only in our minds. So let's take a mind's-eye journey to the surface of this stellar ghost, a voyage into the heart of extreme physics and unimaginable conditions. Maybe your ship failed or you were pushed out an airlock. Perhaps a rogue asteroid struck your vessel, leaving you adrift. The reason doesn't matter. The circumstances of your predicament are irrelevant now. What matters is you're falling, tumbling through the void, with no hope of rescue. You're accelerating toward a white-hot point of light, a beacon of doom growing larger and brighter with each passing moment. The white dwarf's gravity has you now, its relentless pull tightening its grip. There's no escape. Your fate is sealed by the immutable laws of the cosmos. Physics has sealed your fate. The universe is about to put on a show, and you're the star, albeit an unwilling one. Your journey will be a masterclass in extreme physics, a brutal and unforgiving lesson in the fundamental forces of nature. It will be told in forces and energies beyond everyday experience, a symphony of destruction played out on a cosmic scale. It's a terrible way to go, a horrifying end to your journey through the cosmos. But it's a magnificent one too, a breathtaking display of the universe's power and beauty, even in the face of annihilation. You're now a projectile, a helpless object hurtling through space, subject to the whims of gravity and the laws of motion. You're hurtling toward a cosmic diamond, a glittering tomb waiting to claim you. The story of your fall is about to begin, a tale of extreme physics and cosmic horror. The universe is about to show you just how strange it can be, how bizarre and unforgiving the cosmos can be when pushed to its limits. This is the ultimate what if, a thought experiment taken to its most extreme conclusion. And you're the main character, the unfortunate protagonist in this cosmic drama. Let's see what happens next, as you plunge into the heart of this stellar remnant. At first, falling toward a white dwarf feels deceptively like any other fall, a slow, gentle drift into the unknown. There's a certain serenity in the initial moments, a sense of peace as you leave behind everything you know, weightless, silent, almost peaceful. You might even find a strange sense of calm in the face of impending doom. The vastness of space surrounds you, a cosmic ocean in which you are adrift. The star is a distant, brilliant pinprick, a tiny beacon in the inky blackness. It seems harmless enough, a mere point of light among countless others, but don't be fooled by its size. Its gravity is relentless, an invisible hand tugging you ever closer. It's a force you can't escape, a cosmic destiny pulling you towards your fate. Every second you accelerate faster, the initial tranquility replaced by a growing sense of urgency. The feeling of weightlessness begins to fade as the star's pull intensifies. Pulled by an invisible tether, you're now a helpless projectile hurtling towards an unimaginable inferno. There's no turning back, no escape from the star's inexorable grip. The white dwarf grows brighter, its light intensifying with each passing moment. What was once a distant pinprick is now a rapidly expanding source of blinding light. Outshining everything else, it dominates your vision, a cosmic spotlight focused solely on you. The surrounding stars fade into insignificance, overwhelmed by the star's growing brilliance. Even millions of kilometers away, its heat is intense, a palpable wave of energy washing over you. You can feel the temperature rising within your suit, a growing discomfort that foreshadows the horrors to come. Your spacesuit's reflective layers struggle to keep up, desperately trying to deflect the onslaught of thermal radiation. But it's a losing battle. The star's energy is simply too overwhelming. Soon, the side facing the star is seared by radiation, the protective layers failing under the extreme conditions. The suit begins to degrade, its integrity compromised by the relentless assault, while the other freezes in the void, creating a stark contrast of extreme temperatures across your body. Ice crystals form on the shadowed side, a chilling reminder of the unforgiving nature of space. Your speed becomes immense, a blur of motion as you hurtle towards the star. The laws of physics begin to bend and the universe around you starts to warp. Hundreds, then thousands of kilometers per second, you're approaching relativistic speeds, where the familiar rules of reality no longer apply. Time itself seems to distort as you accelerate towards your doom. The universe blurs, the stars become streaks of light, painting the cosmos with your passage. The familiar constellations are unrecognizable, distorted by your incredible velocity. Starlight shifts blue ahead, red behind, a visual manifestation of the relativistic Doppler effect. The very fabric of light is altered by your speed, a testament to the extreme conditions you're enduring. Thanks to the relativistic Doppler effect, the colors of the universe are warped and twisted, a bizarre and beautiful spectacle born of extreme physics. The white dwarf swells from a point, growing larger and larger until it dominates your entire field of vision. It's no longer a distant star, but an all-consuming presence. To a terrifying disk, a blinding circle of pure energy that fills your senses with dread. The sheer scale of the star is overwhelming, a testament to its immense power. A hole in the universe filled with white-hot fire, a swirling vortex of plasma and unimaginable heat. It's a vision of pure destruction, a glimpse into the heart of a dying star. Now radiation becomes your next enemy, an invisible killer that penetrates everything in its path. The heat is intense, but the radiation is far more insidious. White dwarfs unleash torrents of ultraviolet and X-rays, a deadly barrage of high-energy particles that tear through matter with ease. Far deadlier than any sunburn, this radiation is capable of causing irreparable damage to your body at a cellular level. It's a silent, invisible threat that you can't escape. This energy slices through your suit, your skin, your DNA, disrupting the very building blocks of life. Your body is being bombarded by harmful particles, each one causing untold damage. Shredding you on a microscopic level, the radiation is dismantling your body from the inside out. Your cells are breaking down, their functions disrupted by the relentless assault. You'd be dying from radiation poisoning, your body unable to cope with the sheer volume of energy being absorbed. Your organs would begin to fail, and your systems would shut down one by one. Long before you reach the surface, the radiation would claim your life, turning your fall into a slow, agonizing demise. The crushing gravity would be the least of your worries. The fall is a journey through heat, radiation, and the promise of crushing gravity, a gauntlet of cosmic horrors that few could ever imagine. Every moment the environment grows more hostile, pushing you closer to the brink of oblivion. The star's influence intensifies, and the dangers multiply. There's no turning back. You've passed the point of no return, and your fate is sealed. The star has claimed you, and there's no escape from its grasp. The star's grip is absolute, an unbreakable bond that binds you to your destiny. You're a prisoner of gravity, hurtling towards your inevitable end. You're not just falling, you're being unmade, your body and soul torn apart by the star's relentless forces. The closer you get, the more you unravel. The real horror is only beginning, as you approach the star's surface and face the full fury of its destructive power. What awaits you is beyond comprehension, a nightmare made real. Approaching a white dwarf is a journey into the extreme. Gravity near a white dwarf isn't just a pull, it's an overwhelming, inescapable force you can't ignore. It's a cosmic hand ready to dismantle anything that dares to come too close. On Earth, gravity feels uniform, a gentle constant we take for granted. It keeps us grounded, allows us to walk, and defines our sense of up and down. But near a white dwarf, the rules change drastically. Here, the difference between the gravitational pull on your head and your feet is not just noticeable, it's deadly. The gradient is so steep that it spells certain doom. This is tidal force, gravity exerting a differential pull. It's gravity pulling your feet with significantly more force than your head, creating an immense stretching effect. At first, as you approach, it might feel like a gentle stretch, a subtle elongation. You might not even realize the danger you're in. But that initial gentleness is deceptive because it quickly escalates, becoming an unbearable torture. The stretching intensifies exponentially. Your body is pulled apart molecule by molecule, atom by atom. The bonds that hold you together are strained to their breaking point. Bones and muscles are strained beyond any conceivable point of endurance. They're stretched and twisted in ways that defy biological limits. The star's relentless gravity stretches you lengthwise, extending your form into an ever-thinning strand. Simultaneously, it squeezes you from the sides, compressing your width as it elongates your length. You're being extruded, forced through an invisible cosmic press, like toothpaste from a tube, losing all semblance of your original form. Chemical bonds, the very foundation of your being, begin to fail. You cease to be a person, transforming instead into a stream of fundamental matter. Your limbs elongate to grotesque proportions, your torso narrows, crushed by the immense pressure. Your skeleton, once a rigid framework, snaps and splinters under the overwhelming stress. Organs rupture in a moment of unimaginable violence, a catastrophic failure of biological systems. There's no time to scream, no chance to react. The very air is ripped from your lungs, leaving you in a silent, suffocating void. You're being deconstructed, broken down into your most basic components by the universe's most fundamental force. In mere seconds, you're no longer a visitor, an observer, but an integral part of the star's environment, indistinguishable from its own matter. The process is swift, brutal in its efficiency, and absolute in its finality. Here, near a white dwarf, gravity reigns supreme. It is the ultimate destroyer, the final arbiter of existence. This process has a name: spaghettification. You're stretched into a glowing, atom-thin noodle, literally a human filament. Friction and tidal forces heat you to incandescence. You become a fiery ribbon plunging toward the star. The race is fatal. Tidal forces, heat and radiation attack you all at once. Your body is now a trail of dissociated atoms, a cloud of fundamental particles. The universe is recycling you, breaking you down to your simplest form. What was once you is now a glowing stream, about to meet the star's surface. The final act is moments away. You're about to become part of the white dwarf itself. To understand a white dwarf's horror, compare it to the sun and a black hole. Fall into the sun and you're vaporized by heat. No spaghettification, just incineration. A black hole, though, stretches you into atoms before you cross the event horizon. No surface, just endless falling. A white dwarf is the worst of both crushing gravity and a solid diamond-hard surface. It spaghettifies you, then slams you into a surface hotter than most stars' cores. The sun burns you. A black hole stretches you forever. The white dwarf does both, then ends you with a cosmic collision. This is a two-part demise. First, you're stretched into plasma. Then, you hit a surface that's nearly unbreakable. The impact is the grand finale. You're not just falling, you're about to become a bomb. The physics of the fall are brutal, but the impact is even more spectacular. The white dwarf is a unique cosmic executioner. The end is near. The surface you're about to hit is a crystalline lattice of carbon and oxygen harder than anything on Earth. It's supported by quantum mechanics, resisting compression with unimaginable force. You're about to strike it at a significant fraction of light speed. The star's atmosphere is a thin, dense layer. Your plasma stream creates a shockwave as it hits. Friction and compression heat you to millions of degrees in an instant. Your kinetic energy is converted into a burst of light, heat, and radiation. The impact is more powerful than any explosion on Earth. You're not just hitting the star, you're detonating on its surface. The atoms that were you are slammed into the star's core, triggering nuclear fusion. Your fall ends as a brief, brilliant nuclear event. Nuclear fusion powers stars, but your impact triggers it in a flash. The hydrogen and carbon from your body slam into the star's surface, igniting the CNO cycle. Fusion reactions run hot and fast, like gasoline on a cosmic ember. The result, a thermonuclear runaway, a star-spanning detonation. Even your small mass releases energy equivalent to millions of hydrogen bombs. The white dwarf shines brighter for a moment, a colossal flash of X-rays and gamma rays. For an instant, you outshine the star itself. A distant astronomer might see a brief flicker, never knowing its cause. Your substance is converted into pure energy. you've become a cosmic firework. This explosion is your personal nova. Normally, a white dwarf ignites in a nova by stealing hydrogen from a companion star. Here you've become the fuel. Your atoms trigger a runaway fusion reaction. The flash of light is a beacon, racing across the cosmos. Millennia from now, it could reach a distant telescope, a faint whisper of your existence. The fusion leaves behind new elements. Helium, nitrogen, oxygen, now part of the star. You've enriched the white dwarf. Your ashes forever bonded to its surface. Your journey is complete. Stretched, vaporized, fused, and transformed. There's no afterlife, just the cold arithmetic of mass and energy. Your story ends in a flash that briefly illuminates the void. Why imagine such a fate? Because white dwarfs are the future of most stars, including our sun. They're cosmic timekeepers cooling for billions of years, revealing the age of the universe. White dwarfs are also the engines of novae and supernovae events that shape galaxies and measure cosmic distances. Their deaths revealed the universe's accelerating expansion and the mystery of dark energy. When we look at a white dwarf, we see the past, the future, and the key to cosmic understanding. Our fall into one is more than a thought experiment, it's a journey into the heart of physics. It connects our atoms to the life and death of stars. We are stardust, and in the most extreme way, we can return to the stars as fire. Our curiosity about such fates reflects our desire to understand our place in the cosmos. Even if that place is sometimes terrifying, it's always worth exploring.